So first, thanks very much, Hussein, for that excellent overview of some of the big trends we see. I would now like to spend some time telling you of some new announcements we're making across all of our IP families. We will start with our PowerVR graphics family, which is widely respected as the industry leader. PowerVR graphics implements every major standard across all operating systems, including Android, Linux, and Windows. We have been talking more recently that graphics engines are much more than just for graphics. The area of GPU compute is becoming very significant for the industry as we develop next generation SoCs. More of the silicon area is being given to the GPU as it is the most efficient method for processor density. So our Series 6th generation of GPU is designed very much to target this trend. We have established ourselves as an industry leader in mobile and embedded graphics, with around half of all chips in this sector with GPUs having PowerVR, and almost 80% of all chips using non-captive solutions using our technology. So as you will see with this data from a third party, John Petty, the industry has come to respect what we are now doing in mobile and embedded GPUs. So we are now announcing today two further members of our Series 6 family of GPUs. At the beginning of this year, we announced our G6200 and G6400 cores that were the first members of our Series 6 family, striking the best balance between power consumption and silicon area with this new generation of performance. However, a significant number of our customers told us they really want to push performance. So these new cores, G6230 and 6430, are optimized much more for the highest possible performance for the current generation of silicon. All of our Series 6 cores are delivering exceptional performance, starting from 100 gigaflops to more than a teraflop as we evolve and deliver more of the family members. All of our cores use our 6th generation tile-based deferred rendering architecture, which is the key ingredient which enables us to be so successful in this market. And all of our Series 6 cores support our own texture compression format, PVRTC and PVRTC2, which delivers the industry's highest performance, most efficient bit density for textures in graphics. However, of course, all of our cores support all the industry standards, including APIs and texture formats, and will continue to do so in the years ahead. The architecture of our 6th generation is a natural evolution of our 5th generation PowerVR. However, we have focused on significantly increasing the processing density, so you will now see in this diagram where we see USC 0 and 1, that unit in Series 5 was a single processing element. In Series 6, that is a cluster of processors. So the combination of significant increase in processing density, silicon technology, and architectural enhancements for speed means Series 6 delivers up to 20 times the performance of equivalent Series 5 cores. So we are very proud of our progress in graphics. However, I'd now like to move to some of our other IP technologies, starting with video. As Hussein mentioned earlier, our video technology has been extremely successful, with more than 300 million units already shipped worldwide. Our Series 3 video decoders and encoders support every major video format and are highly scalable. They also support both the industry standard OpenMax APIs as well as Windows DirectX APIs, one of the few IP cores capable of this. However, we are now looking for the next generation of video where HD is now creating many more use cases for consumers. We will see applications from mobile streaming to remote services in connected homes to advanced digital cameras through to over-the-top services and many more using new generations of technology such as HEVC at higher resolution displays to 4K and beyond. Our Series 4 cores feature all of the benefits of our Series 3, but now specifically target 4K and beyond display resolutions. They also feature support for 10-bit color depth, which is a very significant step in the industry demanded by the latest display technologies such as OLED. We believe color depth moving to 10-bit is essential, as the industry for many years has been stuck on 8-bit resolution. If you look at the images here, with 8 bits, you will see the grey has very clear contouring, thanks to the resolution limitations of 8-bit coding. With 10-bit resolution, you can achieve the full capabilities of the latest displays, and again, everything up to 4K and beyond resolutions. So we believe with this new Series 4, Imagination is really leading the way in state-of-the-art mobile and embedded video decode and encode technology. I'd now like to move on to our communications technology, our Insigma RPUs. Imagination has long believed that integrating communications on chip, just like we have integrated graphics and video, is the next major step for the silicon industry for SoCs. We believe the Insigma Series 3 technology leads the industry as a multi-standard receiver supporting up to 15 different TV standards. It also supports all major digital and analog radio standards too. However, the key feature is the same engine can also do Wi-Fi and Bluetooth connectivity, including 802.11a, b, g, and n, up to 1x1. The key feature is that this engine, we have implemented all of these standards to class-leading performance levels today. And we are adding new standards all the time to this engine. We are announcing today that in addition to mainstream Wi-Fi certification, we now have full support for Wi-Fi Direct, which is also fully certified. And we have a demonstration of our Wi-Fi Direct technology over here. Please do go and see it, as it shows our capability for very easy consumer connection of ad hoc connections using Wi-Fi, developing every technology needed for ease of use by consumers. I'd now like to move on to our Meta processor family. As Hussein mentioned earlier, you will hear a lot more about our Meta processors in the coming months and years from Imagination. Our Meta processors are full 32-bit, but they feature hardware multi-threading. And we believe passionately that multi-threading makes all the difference to any processor in an SoC architecture, particularly in a unified memory environment. We have a great demonstration here today of how you can use multi-threading to save power consumption just by using additional threads. So please do go and see that demonstration too, though there are many demonstrations to see. Our Meta processor runs full Android, Linux, and various RTOSes, including our own called Meos. But we can configure each thread to be either general purpose or DSP. But the great thing is Meta can combine these two capabilities in a single processor. So today we are announcing that Meta has now achieved full Dolby certification for the latest MS11 portfolio of audio standards. The MS11 capability means that the very latest home cinema and home entertainment standards are now fully supported by the Meta processor. And we believe when Meta Audio is combined with our industry-leading PowerVR graphics and video, we have a unique and tremendous multimedia capability in Imagination. So I hope you can see we are doing many things with all of our IP families as we bring more and more complete technology solutions to our partners. But we are now working very heavily in all aspects of the ecosystems which are essential for successful leading-edge technology. So we are pleased to say that our relationship with the world's leading foundry, TSMC, is going from strength to strength. Indeed, we are delivering a seminar in Taiwan this week jointly with TSMC for the first time to demonstrate some of our capabilities together. One key aspect of this very strategic partnership is that TSMC now works very closely with Imagination to ensure that all of their tools and processes deliver the best possible performance with all Imagination IP cores. Indeed, TSMC has recognized that the GPU is becoming a major technology performance driver in the industry and is now working with us to use our technology to characterize their latest generation and future generation processors. All of our IP family members are being part of this program. One example of this is we have submitted our Meta processor cores to TSMC's Soft IP Alliance. And you will see many more projects and tasks as we work more closely going forward. We are also working with the tool developers for SoC design. One example of these collaborations is with Carbon Design Systems, which a number of our key partners use to model their SoCs. As a result of this partnership, all IP families from Imagination are now available on request to be converted into carbonized models for use in SoC simulation environments. And we believe this is another example of Imagination working across all of our ecosystems from design to production to make the best possible design experience for our partners. As Hussein mentioned earlier, we acquired several companies in the last 18 months, one of which was HelloSoft. HelloSoft delivers industry-leading carrier quality video and voice-over IP and significantly voice-over LTE. This technology is being adopted by an increasing number of carriers and handset vendors as the progression towards 4G and IP networks continues to grow rapidly. So we are announcing today that we have a new partnership with Mavenir, who are a leader in interoperability testing for LTE. The full HelloSoft client has been fully tested with Mavenir's IMS-based converged telephony application server to ensure full carrier-grade compliance with the latest 4G networks. Key feature of HelloSoft's technologies is they are cross-platform, working in software on any processor, any operating system on a very wide range of platforms. I'm also giving you a sneak preview of an announcement that will be made tomorrow, which is under embargo, so please, I would appreciate if you do not say anything until tomorrow morning. But I would encourage you to look for an announcement on something called the HSA Foundation, which stands for Heterogeneous Systems Architect. Imagination believes that SoCs are all designed using heterogeneous processors, which means sophisticated high-performance networks connecting multiple processor architectures within the same SoC. Imagination believes that SoCs are all constructed using multiple processor architectures which are connected using sophisticated on-chip bus networks. Communications where many systems and applications will now be written using a heterogeneous processor combining CPU and GPU. We are also developing our local ecosystem of partners to help our major customers here in Korea to develop complete solutions. And as we continue to grow our business here in Korea, we are strengthening our local office with additional resources in both sales and engineering. And so later today, we will be having a reception with many senior executives from across our partners here in Korea. So with that, I'd like to thank you for your attention, and I'd like to hand over to David, who will then handle Q&A.
Heterogeneous system is not about silicon and integration. That is already understood and people can integrate. It's about software and standardization of making sure you can write applications that work across different platforms. So it's not really a hardware focus, it's a software issue plus architectural rules. So You know, people will combine different combination of things, but as long as they follow certain rules, there'll be tools available for them to have efficient, heterogeneous management of functionality. Just a GPU supplier. I think GPU happens to be an area that we have been hugely successful, and it's been an area that is leading in our technologies. We have been working in multi-standard receivers and processor cores for the last 10 years. I think what you see now is presenting all our capabilities. Different customers are using different technologies from us, but certainly GPU is a leading area.
We have achieved one of our objectives from today. Imagination is about much more than GPUs, and you can see demonstrations of all of these technologies here this afternoon. We talk increasingly about SoCs having three major processing elements: the radio processor for communications, the GPU, and possibly VPU, video for graphics and video, and the CPU for central processing. SoCs moving forward. The key point is only imagination has this unique portfolio across all aspects of SoC processing. In IP and system solutions we have done for our partners. However, as the market matures with high-level operating systems like Android and Linux creating complete application platforms, the dependency on the low-level instruction set for CPUs is going away. We can combine Android on one thread with Dolby on another thread, with a third thread being used for other applications. And this combination, we think, makes it uniquely well suited for the next generation of SoCs. We believe it is well suited for smartphones and particularly for TV and set-top box. However, our plans are for the much broader world of the Internet of Everything, multimedia and processing, and that creates a tremendously effective way to be able to lead new markets.
I think firstly, going back to your question, we are delighted to talk about GPU. GPU is a central part of our business. I think the point we're making is that there's more to imagination than GPU. That's just the first comment to your initial observation. In terms of competitive position against our competitors, in any market such as IP business where there's a processor involved, there's technological advantages and there's ecosystem advantages. In terms of technological advantages, for example, we are the only company that develops deferred shading. You know, people talk about tile-based rendering, and some other people may do tile-based, but we do tile-based deferred shading or deferred rendering. That technology is unique to us, and we have very strong patents on it. And that gives us significant competitive advantage. The Rogue Technologies Series 6 is significantly ahead of competitions in terms of feature set, in terms of bandwidth optimization. In order to achieve maximum performance, you have to minimize bandwidth. And in terms of performance per square millimeter, for devices using SGX, and over 20, or approaching 20 with the Rogue technology. These are significantly ahead of our competitors. And the reason for those is our customers recognize those advantages that I touched on. I think one last point I make on the technological issues, one of the reasons we don't stand up and give details of every feature is that often our competitors try to work our roadmap and plan there. So we discuss a lot of our technological plans and feature sets confidentially with our customers, but it is not possible to declare everything publicly. But there is a whole host of capabilities in our roadmap that ensures we have market leadership. I think the second point I wanted to touch on is ecosystem. Ecosystem is a very important part of competitive advantage. And given that, as Tony presented, over 50% of the market use our GPU, there's a much bigger ecosystem in support of our technology, and that gives us a significant competitive advantage.
I encourage you to see my colleague Chris over here, who will talk through in great detail these issues in the demonstrations in that corner. I will just give you a top-level answer. It's important with any of these technology advances to relate them to real consumer needs. When we look at OLED displays, they are capable of displaying clearly much more than 10 bits of resolution of colour. So as the example I showed earlier was a simple example that if you use 10-bit processing to deliver pixels to OLED, you will see a superior quality image that consumers will clearly notice. But we believe this also has an impact in the encoding space for high-resolution consumer cameras. So user-generated content will be an increasingly powerful driver for state-of-the-art display technologies. So by combining our D4500 and E4500 cores, we can drive the industry forward because users can immediately benefit from this technology with their 10-bit cameras playing onto 10-bit capable OLED displays. We also know of many leading broadcasters and content generators in both TV and film that are very keen for the industry to move beyond 8-bit resolution. Very compelling key feature for future generations of TVs, cameras, and any product using. Please do visit Chris afterwards, who can show you in more detail